I think by now we've all seen those images. I won't share them here, I know they can be distressing. But images of wildlife caught in plastic waste, such as sea turtles with plastic straws wedged into places they very much do not belong, have become a rallying cry in favour of discontinuing our use of single-use plastics. But plastic pollution goes far beyond some plastic straws and single-use carrier bags. Our lives are, quite literally, saturated with plastic in so many forms. We encounter plastic around the food we eat, the water we drink, the clothes we wear, the products we use, and even the air we breathe. Plastic is a problem, but how do we solve it? Hi, I'm Dr. Eleanor Tufnell, an environmental scientist, and today I'm going to talk about the ways plastic pollution affects the environment, from production to disposal. We'll explore ways to reduce our plastic use, and examine how plastic can be replaced on both the small and large scale. Pollution from the production of plastics. When we think of plastic pollution, we tend to think of plastic's end-of-life disposal, but the production of plastics is a major source of greenhouse gas emissions. This starts even before the production line whirs into life, because plastic is made from oil, a fossil fuel which releases CO2 and methane during its extraction and refining. Ethylene, which is an important plastic feedstock, releases methane during fracking and transport. Greenhouse gases are also emitted from plastic manufacturing itself. The production and disposal of plastics is responsible for around 3.3% of global greenhouse gas emissions. To make the plastics requires substantial quantities of energy, much of which is currently sourced from coal or natural gas, and thus responsible for even more greenhouse gas emissions. The shipping of raw materials for producing plastics, and of course the finished products, results in CO2 emissions. The increasing demand for single-use plastics in particular raises our dependence on fossil fuels, furthering environmental degradation from both fossil fuel extraction and plastic production, and worsening greenhouse gas emissions. Terrestrial plastic pollution. Terrestrial ecosystems have been badly affected by plastic pollution. While we see littering as an eyesore, we rarely grasp the damage it can do to the environment. Plastic can alter the physical structure of habitats, smother vegetation, choke waterways, and block sunlight from reaching plants. Wildlife can mistake plastic for food, which can cause impaction, toxicity, or starvation, all of which can be lethal. As plastics do not decompose in the way that organic material does, they can accumulate and contaminate the soil. This contamination harms everything in the soil, including earthworms and beneficial microbes. Damage to these populations degrades soil health, and this harm cascades up the food chain. Fewer earthworms means less food for creatures that eat earthworms. Marine plastic pollution. Every year, 400 million tons of plastic waste is generated globally. While estimates vary, recent high-quality studies have estimated between 1 and 2 million tons of that enters the ocean every year. So about 0.5% of global plastic waste winds up in the ocean. This is a small percentage of global plastic, but it still has a big impact. It's estimated that every year 1 million or more marine animals die as a result of plastic pollution. All trophic levels of the marine ecosystem are affected by plastic pollution, from tiny phytoplankton to corals, birds, turtles, and even the mighty shark. Both seabirds and turtles often mistake plastic for prey, and once eaten, plastic reduces stomach volume, potentially leading to starvation. The toxins in the plastic can also damage kidney function, inhibit various vital enzymes, and stunt growth. Plastic can also cause fatal constipation, known as impaction. Sharks may not be killed outright by ingesting plastics, though research is still ongoing on the effect eating plastic has on sharks. But many sharks are killed when they become entangled in drifting nets or other plastic waste. Sharks are far from the only creatures to be injured or killed by entanglement with plastic waste. Both in the sea and on land, birds, mammals, and other creatures suffer this fate every year. Microplastics. So far, we've covered what might be termed macroplastics, large pieces of plastic and their effects on the environment. But this is not the only form that plastic pollution can take. The term microplastics was first coined in 2004 and refers to particles of plastic that measure less than 5 millimeters. They can be divided into several categories. Primary microplastics, which are intentionally made tiny, such as microbeads used for facial washes and plastic-based glitter. Secondary microplastics are the fragments of originally much larger plastic products and is formed by mechanical, chemical, radiation, or biological degradation of those larger plastics. Sadly, smaller plastic does not mean smaller problems. As I discussed in a previous video, soils are a vital and usually very effective means for carbon sequestering. However, microplastics in soil reduce its ability to store carbon. This affects agricultural and ecosystem productivity, in addition to hindering our efforts to remove excess CO2 from the atmosphere. Microplastics also modify soil structure, diminish soil fertility, and disrupt the natural nutrient cycle, which is essential for plant growth. Coral, a life form already struggling with rising ocean temperatures and acidity, is also impacted by microplastics, which seem to increase disease risk among coral. Those phytoplankton mentioned in the last section, well, aside from being a major food source for many marine animals, they are crucial for CO2 absorption into the ocean, making them vital to ocean sequestering of carbon. And they also produce between 50 and 80% of Earth's oxygen. Phytoplankton often attach to microplastics, which can damage their cells and inhibit their ability to photosynthesize. As microplastics can be ingested by many different creatures, from tiny insects to large mammals, this means it can bioaccumulate, increasing in concentration up the food chain. Along the way, these microplastics absorb toxic chemicals from the environment, which adds to the impact on the health of wildlife and of humans, as we also consume food, water, and air contaminated with microplastics. One study suggests that on average, we may consume around 5 grams of plastic a week, which is comparable to eating a credit card. Yes, you heard that right. We're all eating the equivalent of a credit card every week, which is very alarming given the health problems that have already been linked to microplastics. While research is still ongoing and our understanding has a long way to go, we already know a few rather concerning things. Microplastics have been linked to endocrine disruption, inflammation and oxidative stress, and are believed to be potentially carcinogenic. The worst offenders. The iconic images of plastic waste's harm tends to be of single-use plastic straws and grocery bags. But which industry actually produces the most plastic waste? Packaging accounts for 40% of the world's plastic waste. This includes a lot of things. One example is the humble plastic bottle, which takes around 450 years to degrade. Other industries include building and construction, transportation, personal care and consumer products, electronics, industrial machinery, and textiles. Farming and agriculture contributes to plastic pollution too. For example, plastic mulch. Yes, that is an actual thing, which is used to control weeds and increase soil moisture retention. Of course, once this plastic is in the soil, it contributes to all the harms previously discussed, both to the soil and to any waterways it may leach into. Aquaponics and hydroponics can be environmentally friendly in terms of efficient water use, but unfortunately, they often rely on plastic components. Plastics are also used on farms for irrigation systems, greenhouse coverings, or animal housing. But the generation of plastic waste is not evenly distributed throughout the globe. The World Bank estimates that high-income countries are responsible for an average of 215 kilograms of plastic waste per person every year. The bulk of plastic waste is created in the US, Europe, and China. Lower-income countries generate significantly less plastic waste, but unfortunately they tend to suffer from the highest plastic pollution. Let me explain. Plastic waste just refers to waste plastic. It only becomes plastic pollution when it enters the environment. Wealthier countries can generally afford much more efficient waste management than poorer countries can, allowing them to collect, safely dispose of, and properly treat plastic waste before it becomes a pollutant and leaks into the environment, while lower-income countries may lack these facilities or the money to properly process plastic waste. And to add insult to injury, much of the plastic pollution experienced by lower-income countries was generated by high-income countries, then exported to them for disposal. High-income countries account for around 89% of global exports of plastic waste. Disposing of plastics. This leads us on to the question, how is plastic disposed of currently? Well, some is recycled, around 9% in fact. About 50% ends up in landfills, and roughly 19% is incinerated. The remaining plastic is either dumped in open, insecure dump sites, burned in open pits, or leaks into the environment. While it's commonly believed that plastic never degrades, this isn't strictly true. It does, but it takes a very, very long time to fully degrade. And as it decomposes in landfill, it does so anaerobically and releases methane, a greenhouse gas. Burning plastic waste releases CO2 along with toxic chemicals and black carbon, none of which are good for the environment in general or climate change in particular. So why isn't plastic recycling higher? Well, to understand that, let's look at how plastics are recycled. Plastics can undergo either one of two types of recycling: mechanical recycling, which maintains their original chemical structure, or chemical recycling, which alters their chemical composition. At present, mechanical recycling of plastics is the most commonly used method. An advantage here is that you can create a closed loop, creating new, identical products using recycled products. But this requires high quality and very specific like-for-like inputs. More common are open loops, which create products which serve different purposes from the original plastics. Chemical recycling is very efficient for mixed plastic waste, thus reducing the difficulty of sorting plastics into their different types before recycling, but is limited due to high energy requirements and the strain caused by the intense reaction conditions required. Without getting into the complexities of polymer chemistry, what you need to know is that there are a lot of different types of plastic, and most aren't particularly compatible, meaning it is difficult to recycle different grades of plastic together without degrading the plastic's properties. You may put in higher quality plastics, but only get out lower grade ones. This requires plastic recycling to be sorted, then processed separately from each other, which adds time and cost, making recycling less economically viable. Recycled plastics often only undergo a small number of cycles of recycling, with only around 10% undergoing multiple rounds. Worse still is that many recycled plastics are mixed with virgin plastics in order to maintain the desired properties of the plastics, thus increasing the demand for more fossil fuels for more plastic production, rather circumventing the advantages of recycling. But present humans with a problem, and they won't rest until they've figured out some solutions. Advanced techniques such as solid-state polymerization, for example, can enhance polymer chain reassembly and strength, and does this by heating the polymer without reaching its melting point. Significant improvements to the efficiency of recycling and the quality of its results are possible, with great scope for unlocking the true potential of plastic recycling. What we need to make that happen is public pressure, political will, and the money to finance first the necessary research and then the rollout of these improvements. Reducing plastic use. But recycling is the end-of-life option here. We can lower the amount of plastic waste produced in the first place by prioritising multi-use plastics and reusing them wherever this is feasible. So, for example, buying a long-life plastic drinks bottle or coffee cup that you can refill over and over, rather than using a single-use bottle. The bottle might be made out of recycled plastics, or better yet, you could try bottles or cups made from other materials such as metal, bamboo, glass or ceramics. Single-use plastic shopping bags are largely being phased out in many countries, incentivising people to buy long-life plastic bags instead. You might also try a cloth bag, which can be entirely free of plastics. To avoid the old, "oh no, I forgot to bring the bags" problem, I carry multiple cloth bags on my person at any given time, including in my handbag and various pockets, and have gotten into the habit of putting reusable bags back into the car boot immediately after emptying them. For certain disabilities, the flexible disposable straw is a very necessary piece of kit. But if you don't need the disposable plastic straw, switching to steel, glass or silicone straws is a good way to reduce plastic waste. So many products come in unnecessarily large quantities of plastic packaging. It's not always possible to choose brands or products that have little or no packaging, but when it is possible, I would recommend it. A lot of common products such as detergents can be refilled, and a large number of eco-friendly companies now exist, allowing you to refill your bottles of laundry liquid, soap, shower gel and many others. Alternatives to plastics. As I mentioned in a recent video on the closure of the Strait of Hormuz and its environmental impacts, scientifically speaking, it should be quite possible to replace all petrochemical-based plastics with bioplastic alternatives. Bioplastics can be sourced from renewable materials, which massively decreases our reliance on fossil fuels and lowers greenhouse gas emissions. Some bioplastics can even be composted. The challenge is more that these can be more expensive, so finding cost-effective methods for creating them is a must. These also have their own environmental concerns. For example, deforestation for their feedstock, as many bioplastics are created using plant biomass, and if poorly managed, this could lead to damaging deforestation and reduced carbon sequestering. When trying to replace plastic, the problem we come up against is just how useful it is. It's lightweight, can be flexible and durable. Finding alternative materials that fulfill the necessary role can be challenging. Look at drinks bottles, for example. We can replace them with glass, as was done for years before plastic came along, but glass can be brittle. Glass is also heavy, which increases transport costs for the bottles and their contents, as well as increasing greenhouse gas emissions as more fuel is needed to transport them. Maybe you choose a can of drink rather than a bottle. Well, sorry to tell you this, but inside the aluminium can is an incredibly thin lining of plastic. This stops the acidic drinks corroding through the metal and means that your beer doesn't taste like licking a battery. Yes, this can affect the taste, hence why many will argue that a Coke from a glass bottle tastes better than one from a can. Glass is inert, but the polymer isn't. Many tea bags are made with plastic, so switching to loose-leaf tea can help lower plastic waste. In theory, since that loose-leaf tea also probably came in plastic packaging. Please don't just throw out your existing plastic items, at least if they're still in good working order. But when it comes time to replace them, maybe think about alternative options. These are becoming increasingly cost-effective and available, so give them a go. What can you do? I've covered a number of things we can do on an individual level, reducing our use of plastics, reusing plastics, and recycling them. And naturally, I would encourage you to properly dispose of your plastic in the appropriate bin rather than, say, littering. But are these individual choices enough to make a big difference? No, not even close. Look, I'll level with you here. Individual action is fantastic, and I heartily encourage you to continue to do things like recycle. It's awesome. But unfortunately, as is the case with many global problems, individual action alone cannot produce change on a large enough scale to make enough of a difference. Fortunately, we're not alone. So what other options do we have? 2 words: collective action. Writing to your elected official is good. Writing to them as part of a large campaign of like-minded people is even better. Politicians and businesses can afford to ignore individuals, but the more voices that call for change, the harder they get to ignore. To accomplish this, you have a lot of fantastic options, from global charities and NGOs to small, local community groups. Some may have a broad focus on many environmental problems, others may be more narrow. You can, of course, join or donate money to these groups, and that tends to be very helpful. But there are also a lot of free or low-cost ways to get involved. Get on their newsletter so you know about petitions or letter-writing campaigns. Share their content on social media to raise awareness of the topic. Some may need volunteers for a variety of tasks, from distributing leaflets to collecting litter. One thing I have found over the years is that people struggle to understand threats in the abstract. When they hear some big charity talking about plastic bags and turtles, they can tune it out as not relevant to them. But when their friends, co-workers, fellow volunteers, family members, etc. start talking about their concerns about how microplastics might be harming their kids, or how angry they are about all those plastic wrappers littering the park, it can feel more personal and more immediate. Altruism is a thing, and people can and do help out strangers. But it's a lot easier to care if the person talking about a problem is someone close to you. Helping to change minds can be one of the most important things we can do to help save the environment, and it all starts with connecting to others. It's a bit of a cliché at this point, but we really are stronger together. Conclusion. And on that note, I really hope you found this video helpful and informative. Part of my goal with this channel is to make often complex topics accessible to a wider audience. I suspect anyone who made it this far into a video on plastic pollution was already pretty invested in the topic, but I'm still grateful you stuck around. I hope I've given you ideas and inspiration. If you liked the video, do me a favour and hit subscribe, like the video, comment, and share it with anyone who you think might find it interesting. As always, I have left a library of links in the description, so please check that out if you want to learn more. So until next time, thank you for watching.